Why don't we get started? My name is Brett Lindsley. I'm with STA Group. This particular training track on CJUG is to present common technologies that we see in the industry. Hopefully it'll broaden up people's interest in some of these technologies. If you haven't used them before, hopefully it'll give you a little bit of interest to try them. And tonight's presentation is on Cravin Maven. Hopefully at the end of this presentation, everybody's going to be craving to use Maven. Actually, in learning Maven, just a little bit of a backstory on this. When I first was introduced to Maven, I learned it the wrong way, because the first thing I was presented with was, here's a whole bunch of XML files. Go figure out what's going on with the build. And to tell you the truth, I had no clue. Okay? So hopefully this presentation will demystify what's really going on with Maven. So somebody hands you a build file with a whole bunch of XML stuff, you say, I really know what's going on. And that's really what I want to convey tonight. Okay, so what is Maven? Well, of course, it's a Yiddish word meaning accumulator of knowledge. Every software package has to have some kind of a fancy name, otherwise nobody pays attention to it. So more specifically, it's a standard way to build our projects. It gives a very clear definition of what our project consists of, and it's an easy way to publish the project information for people can see how the project is being put together. Also, it's a good way to share jars across several projects. Many times you have many projects use the same jars. Maven makes this really easy to do. But the very short definition of this as well, it's really a plug-in execution framework. So if you want the very short, simple phrase, it's a framework and everything is done through plugins. So it really makes it really easy to understand how it works. So why use Maven? Well, dependencies are a major problem. They're always difficult to manage. Many times there's many projects involved, a lot of different dependencies. This jar is dependent on that jar. Many different organizations involved. Somebody creates a jar, there's different versions. This is really a challenge to try to manage. Maven makes this fairly easy to do. What's also important is there's a common directory layout that's used. And this is easier for new developers. You say, OK, this is a Maven project. They immediately have a good handle on what folders are doing what and how the project is laid out. So really, it's very important to have some commonality between the build process. Declarative dependency handling. And this I will hopefully have time to show a little bit later on. There's really a lot less surprises because it's a lot easier to have declarative dependencies rather than trying to do everything yourself. And also, this is very, very important. There's a strict life cycle that gives a predictable build sequence. So within Maven, you know exactly what's going to happen. There's a series of steps that happen. And if you understand that those steps are going to be happening, you can pretty much understand how the build sequence is going to happen. We have report generation. And it's also a good way for developers to collaborate on the different dependencies they're using. But really, for CJUG tonight, it's commonly used in the industry. And this is what I would like to present, is the fact that it's hard to go anywhere and not run into Maven nowadays. A lot of people are using it. If they're not, they probably will be. Hopefully nobody here is using Make anymore. I assume there's probably some people using Ant. Maybe we can try to we'll convert you over here, Freddie. But the idea is that this is fairly common, and you're going to run into this quite often in the industry. So let's have a little bit of a comparison between Ant and Maven. Most people have grown up on Make and then Ant, and hopefully we can be moving on to Maven. Within Ant, we've got the build XML file that controls everything. With Maven, there's what's called a POM file. You'll always hear this comment about, this POM file does this. In Ant, you have a lib folder. You throw all of your junk in there, and then you kind of wonder how it all works. With Maven, we have a repository, and it's very well structured. This well-structured repository gives us a very easy way to understand the data organization. With Ant, one of the biggest complaints I have is that you can do any type of scripting from scratch. You can write anything you want. Every Ant file can be completely different. You go to a different organization, they completely do their builds differently. And it's not that Ant is hard to understand, but how people use it is hard to understand. With Maven, we've got this predefined build cycle, and I keep on stressing that because that's really going to make things a lot easier for us. Then there's some other additional things. Ant doesn't have an inheritance model, and there's really no formal convention, so every time you see a project, it's laid out differently. With Maven, at least, we've got some conventions that people adhere to, which makes it a lot easier to work with, and things are declarative. So the operation model, well, I took a nice, beautiful model, Vanna White, and rather than flipping letters for us, hopefully she'll flip some interesting squares for us. So how does this thing really operate? Well, this POM model is part of the overall design of Maven, and this is really a description of how your project is laid out, how it's put together, and how all the dependencies are all managed. The next square is the dependency management model. This describes how do we interact with all the different dependencies in our project and also with external dependency information. We'll see that there's these repositories where Maven gets its information from. dependency model tells us how to get that information into our project. We also have the project life cycles and phases. I've been commenting on that. And the other important part of it is plugins. So we'll see that really the whole operation of this is based on having these plugins into this particular model doing certain things. What's really important is we have all these components, but it's really important to understand how do these components actually do something useful for us. So we have the interaction model. We have all those components, and the project object model, the POM, interacts with a file called the POM XML, which is usually what most people think when they think of Maven. Oh, we got this POM file. The POM file can be hierarchical. It can span multiple different modules. This interacts with this dependency model. The dependency model manages all the information going in and out of the project, namely the repositories. And we'll talk in more detail about that a little bit later. The plugins, though, are interesting because we have many different types of files in our particular system. We have the source files, generated files, resources. And what happens is the plugin will actually start operating on some of these files, and it will do certain types of transformations and operations on these files. So as these plugins begin triggering, our project begins building, and things start happening with Maven. Some important concepts. So this is going to be the execution model, and this is the most important thing. He's kind of pointing like that too. This is the most important slide of the entire presentation. If you remember this slide, by golly, if you walk into an interview, they said, do you know Maven? You go, yes, here's the slide. This will show you how it works. You can forget my name, but don't forget this slide. This slide's going to tell you how everything works. And what's interesting is that it's only one slide, so once you know this, you'll know everything about Maven. It's really not that hard. So let's see what it really is doing. We've got these things called life cycles. I've been talking about that. Maven, by default, comes built in with 3 types of life cycles. There's a clean life cycle, a site, and a default. Clean is used for removing things. It gets rid of files. It gets rid of stuff. And you can program it to do a lot of interesting things. Site is usually used for documentation and stuff like that. When most people think of Maven, they usually think of a default life cycle. That's where we do this building, where we put things together, assemble things, generate stuff. So these 3 life cycles are part of Maven. They're already predefined. You don't have to define them. They're already there. These life cycles then are comprised of these phases. I show 4 phases on here, 2 and 6. But there's actually many, many different phases. So basically, what Maven does, it says, for this given life cycle, here are the steps I'm going to go through. It will always go through these steps. You can't change it. They're there for you. So this gives you this predictability in terms of how things are being built. You can actually go from phase to phase and say, well, this phase, this is going to happen. In this phase, this is going to happen. So you know exactly what's going to happen at every single step of the execution model. Now we've seen that we have these plugins, and these phases then are bound to the plugins through different goals. So some particular phase of our life cycle is going to say, I've got this goal that I need to accomplish. It does that by calling some specific plugin to do the actual work. So as an execution framework, we have Maven providing the life cycles and the phases. They can go get many different plugins from various places, put them together. As it marches through this life cycle, it's going to go ahead and trigger all these different plugins to do all the work. So really, if you look at the POM files, that's kind of like the hard part, because it's telling you about what all these plugins are doing. And this is really the easy part, how the whole thing actually operates. So again, keep in mind this one slide. It'll get you your next job. If you say, do you have to know Maven? You go, yes, I know it. I saw it at CJUG. Okay? So we have some more interesting things. We've got the built-in life cycles. And this we just got done talking about, but it's here for reference and some more details. The phases, again, are part of the life cycle. What's interesting is that the goals sometimes have phases. Sorry, let me say it the other way around. The phases may have certain goals bound to them by default. We'll take a look at what this does. What's really interesting is that given a particular type of project that you're building, Maven will automatically configure the phases for you. So again, you don't have to try to figure out everything yourself. A lot of this is being done for you. It's already pre-bound by Maven. So lifecycle goal, and we looked at that a little bit earlier. The goal is really the unit of the work. This is really what's going to happen during some particular lifecycle phase. And the goal binding is interesting, because the goal can be bound to any lifecycle phase. If we have a particular plugin, or if we made our own custom plugin, we can bind it to any phase that we want. You can bind the goals to multiple phases if you want. So you can do very interesting things like that. If you have multiple goals bound onto the same phase, they're going to execute in the order that they're declared, which is fairly typical. And goals can also be manually executed. How many times do you see somebody type in Maven clean, right? Well, you're manually executing that plugin to do something for you. So you can actually execute these things directly from Maven if you wish. So the default build phases. As an example, if we're doing packaging types like EJBs, WAR files, which most people are familiar with, Maven will automatically define certain phases to have specific goals for you. You don't have to go figure out how do you hook all this stuff together. It's already hooked together for you. So we'll process resources, compile, do the tests. Packaging is interesting. That's where it actually generates the actual type of packaging. WAR file is what I typically use. Though what's interesting, the last two steps are interesting. And a lot of times you see people type in Maven install, Maven install. What's really going on? Well, really the install phase is where it builds up your actual project, and then it moves it to your local repository. So that's what the install phase is doing. The next phase is called deploy, where you can actually move it to any place else that you want. If you want, you can move it to an artifactory. You can send it across to a different foreign country. Do whatever you want with it. So this is really the last step, which is the deploy. Most of the time when you're doing local development, you don't want to move your artifact out someplace until you're really sure that it's working. So usually you do the Maven install as your most typical command. These are all the phases of the default lifecycle. We showed about, what, 6 in the previous slide? Well, if you want to do anything with the other life cycles, there's plenty of different things you can play with. So if you want, you can attach a plugin to any one of these phases, and you've got all these things predefined for you. So there's a lot more stuff. If you start digging, it can become very interesting where all the stuff is really happening. But again, it always starts out the fact that this life cycle is predefined. You're going to start with the validate, go down the left side, the right side, come down to the end. You're done. You can't change the order, but you can hook things onto these steps as you wish. Plugins. Let's look a little bit more at these plugins and what's really going on. Plugins are hooking everything together, and this gives the goals to the lifecycle phases. And as I previously commented, that these goals can be bound to the life cycles in any way. But really, a plugin is actually just another jar file. If you think about it, jar file is what we're hooking into our program. So Maven just treats these plugins just yet another jar file, goes, pulls it in, and executes it. Sometimes you hear about Java Mojo classes. This is basically how these plugins are actually created, how you actually write one. So if you actually want to write one, you'll hear people talk about Mojo classes. Actually, a big thing about this presentation, too, is a lot of the terminology, because people throw this terminology around when you talk a lot about Maven. And hopefully, I'm bringing everybody up to speed on all the terminology that people use when they're talking about the Maven technology. So some of the supported plugins, again, all this stuff comes free for you. You got in the core, you've got the stuff for cleaning, compiling, etc. Packaging, there's many types of packaging that Maven will do by default. Report generation, everybody loves check style. We can't get away through QA without check style. Plenty of tools. Well, yeah, I can do Ant, but we won't say that you can run Ant scripts from within Maven. We won't tell you about that. But you can do all kinds of other interesting things. And we'll see later using a tool called the archetype, which is also very interesting. There are some IDE-specific commands. If you use Spring Toolset, that's already integrated for you, so you don't have to worry about that. And if you want more details on all the plugins that you can find, there's some repositories out there. So let's take a look at these repositories. What exactly are these repositories doing, and how do they work? Well, we have the local repository, which is on your local machine. This will keep all the project dependencies. So when you're building, all the jars that you're working with are coming from your local machine in this local repository. By default, it has some location. You can always override that if you wish. There's a central repository. This repository is provided by the Maven community. This is where you're going to find almost all of your jars. If you want to find a jar, you don't have to start Googling for it. Almost everything you're going to find is in the central repository. This is actually pre-configured by the Maven build cycle, so you don't have to even specify it. It's already there. We also have what's called a remote repository. These are custom repositories for specific libraries that might be using. So if your organization has some specialized libraries that they're working with, you set up an artifactory, you put your jar files in there, then you can directly access them with your project. And also the last one, this is sometimes called a deployment repository. It's not really a repository, but sometimes it is referred to as one. As indicated, the very last phase of Maven is to do a deploy where it moves whatever you built to some remote location. This is sometimes called the deployment repository. And what's interesting, you can do various protocols. You can do an FTP, you could do an HTTP post, you can send your file anywhere that you want. So there's a lot of very interesting things you can do. As an example of the local repository, this is off of my machine. On the left side, I went into my users Brett L M2 folder, and you see the repository folder. That's there. But there's also a special file which I want to bring into the discussion. This is called your settings.xml. This file you will also see, so you'll see POM files, but those are for each project. That gives a description of how the project is being built. The settings file, though, is on your local machine, and that applies to everything that you're doing. If you think about it, you got this POM file in your project. Do you really want to put your username and password in that and send it around to everybody? No, you don't want to do that. So if you're doing stuff like credentials and stuff that you don't want to put into your project, you put it onto your local machine here. So you do your build, the information from the settings is taken, and then your project gets packaged up, but you don't send along all that important stuff like your usernames and password. That stays on your local machine. If you're going through a continuous build cycle where you have other machines which are doing the builds, they will also have to have some way to access the information. They're going to have their own settings file. But again, think about the settings file as basically your own local environment that you don't want to really give to everybody else. On the right here, we see expansion of this repository. We see that those are all the interesting things that I've been using lately. You got Postgres, Stacks, Velocity. These are all the different types of modules that I've been using. If we expand this out one more level, go all the way down to the bottom, Postgres, this is where the jar shows up. So basically, this repository is hierarchical. It's easy to understand. And in the very bottom, this is where all the jars are. Now, the repository is automatically built whenever I do the Maven build cycle. So you don't have to go manage all these folders. You don't have to go find a bunch of jars. You don't have to drag them back and forth and remember which ones are new or old. It's all taken care of for you. So let's take a look inside the POM file. It's always a little hard trying to read through XML, but of course, when we get down to it, the POM file is what tells you how your program is actually being built and how it's put together. So I want to take a look at some of the highlights of what you're going to see. So if you look at it from the point of view, these are some of the things you're going to see in POM files. Let's take a look at some of the important things that are going to show up. The most important thing is that every POM file has what's called the artifact coordinates. So this basically gives you some location and some unique identification to the particular artifact that you're working with. In this particular example, POM, when it gets built, you see I have a packaging of type jar. When this gets built, it's going to have a specific group ID, an artifact ID, and a version. Given those three pieces of information, you can uniquely identify any particular artifact. Question?
The keys actually includes the packaging. Jar is assumed, but you can have a jar and a war with all the same stuff. That actually takes all four to uniquely identify.
Yeah, but the coordinate specifically is typically the triplet of information. So we can get more specific. The fact that the actual artifact that's generated also depends on the type you're generating. But if you talk about the actual coordinate, the triplet of information identifies it would be these three. OK, so if we take a look at an example dependency, we've got, for example, a dependency on JUnit. Well, we all love writing unit tests, right? That's the most exciting part of coding, right? Okay. There's actually a presentation thinking about how to make unit testing a little bit easier with some other special plugins. But this is how you get the dependency for JUnit into your application. We have the group ID, artifact ID, and version again. There's also another dependency I'm showing here. And this is a 1.0-snapshot. That's kind of a strange way to represent a dependency. But I'll show you in a moment what that actually does. OK, so dependency scope. This is something else that you will see. And basically, on the left, we're showing a dependency, which is the Mockito. Well, the only time you really use Mockito is when you're doing testing. You don't use that when you're running an application, so why build those jar files into your application? So therefore, we say that this particular dependency is only used when you're doing the testing. Don't build that into my end application. Also on the right, we have another example where we say the scope is provided. The actual JEE libraries, it's like, well, that's going to be provided by our Tomcat server. You don't have to put that stuff into the actual WAR file itself. So again, we've got some different scopes that really define when some of these particular jar files are going to be used. OK, so let's take a look at what this Maven snapshot is. If you've got a large software application with multiple modules, multiple teams, there's always challenges communicating versions. It's like, well, I updated this, and I checked this in. Well, I now changed that. And then you send somebody a jar through email or something. It gets kind of hard to keep track of what's going on. So the whole idea of the snapshot is that you specify the version as being a snapshot, which gives it a special version number that says, OK, whatever is currently being deployed. So therefore, you don't have to worry about having the latest jars. It'll actually figure out what that is. So unlike the fixed version where you say, I want that specific version, Maven will check for the new snapshot version when you're doing your builds. So basically, we have to convert that eventually to some fixed number when you really want to go through final build cycles. And there are some tools for doing that. There's the release and the versions, which will actually convert in your POM file things labeled as snapshot into actual versions that it currently got done building with. So here's an example plugin. I have this wonderful application called the Media Muncher. And at the root parent, I'm defining a property so that I'm going to start hinting at how we do multiple module projects. We got a web service client on the bottom. And what's interesting about this particular plugin, you can see all the interesting stuff that we've been talking about, the artifact ID, the version, some dependencies. What's also interesting about this is this one actually talks about the phase, where we say, well, during the phase of process classes, this is where we want this plugin to trigger. Configuration, then, you give it some interesting information. And then the goal that it's going to do is a Java to web service. I talk about this as being one of my favorites because it saves you a lot of work if you want to convert Java into a bunch of web service actual WSDL file. So in order to generate the file, yes, you can go ahead and manually type that in and try to remember what the command line is and hope you've got everything installed properly in your paths. Or you can just have it as part of your build cycle. Give me the WSDL file for this web service. Multi-module projects, I've been kind of hinting at that a little bit. They have a slightly different format. Basically, the packaging is type POM. If you see this, it says, OK, this is going to be a multiple module project. And somewhere in there, you're going to see a module statement. And the modules then list all the different children projects, modules at that particular level. So this is how you can start separating a project into different levels and different types of hierarchies. And this is very, very handy when you want to put all the common stuff in your top parent. So if you have a bunch of jars that everybody else has to use, throw all that stuff up in the parent. If you change it once, it's going to change everything for all the children underneath it. Very useful capability that don't see in some of those other build tools. OK, some other odds and ends I'd like to talk about here. Archetypes. Archetypes is a very handy thing to have. This is the Maven project templating toolkit. So basically, an archetype is a predefined type of Maven project. So you say, well, I need to create a WAR file, or I want to create a web app. But how do I do it? Well, you just type in the archetype. It'll generate one for you. Sometimes it's very useful because it'll show you how to do things, how to organize things. It may not be exactly what you want, but it gives you some pretty good ideas. And there's literally hundreds of these things out there. So you can find these archetypes for almost anything that you want to do. And I'm going to show in a moment how to do this. So this is an example. If I type in Maven archetype generate, it's going to tell me about all the different archetypes that are available. One particular archetype I'm going to execute in a moment is going to generate a web application just from this command line. And in STS, you can also do this fairly easily. All you have to do is just say, we've got a Spring project. I want an MVC project, and we'll create an MVC Spring project for you. So it's very handy to use. Some of the common Maven commands. Usually you see people type in Maven clean. Well, that's going to remove all these old past build files, junk that you don't need. There's some variations to this in terms of what it's going to remove, but typically use it to get rid of what's called the target directory and all these stuff that it generates from that, the old stuff that you don't need. Maven install. If you type in install, it's going to execute the default lifecycle, and it's going to stop at the install phase. The reason I'm putting this here is many people just type in Maven install. Well, what does that mean? What's really happening here? It's going to run through all of the life cycles, the default life cycles up to install and run it, but it's not going to go any further. So this is very important to understand because somebody might type in Maven generate sources. Well, it's going to start at the very beginning, do the verify, but it's going to generate sources, and then it's going to stop. This way you can control how much of the life cycle you actually want to process. It's very handy when you're developing and debugging. Maven check style, well, we all have to do check style in our code, but this is an example, again, of something that you execute manually. Check style is called check style. What that means is check style is the name of the plugin, and check style is the name of the goal. So they just made them both the same name, maybe just to make it harder than it had to be. OK, so let's take a look then, in summary, what we have for Maven. In summary, this is really based on the central concept of a known build cycle. Very, very important because it makes it easy to understand what's happening at every single step. And given the fact that we have this clearly defined build cycle, it's really easy to understand how the project is really being built. All the work that we have in Maven is actually being done through these different plugins. They do all the work, and it's really only necessary to learn a couple of simple commands. As we saw a couple of commands, you're using Maven. It's really pretty easy to get going on it. And what I'd like to do next then is to give us a brief demonstration on some web applications, how to generate a web application using an archetype, and also how to generate a web application using Spring, which is also very interesting. And I'll give an example of a demonstration. Actually, what I'd like to do is take a brief break right now and see if there's any questions on the presentation part before I go through some of the demonstration of how it works. Any questions? Do we have any Maven experts here? Okay, so we got one kind of an expert here. Because if I can't answer it, you can. You got another Maven expert there? Oh. Okay, good. So I got questions I can't answer, you can answer. Sorry, you got a question then?
Yeah, so you said the steps in the process then are always cumulative, meaning that if you choose Maven test, you're going to run all the steps prior to and up to including the test?
Yes, exactly. So the further down on that life cycle that you choose, it's going to always start at the beginning, go all the way down and stop at that particular life cycle. So this way you can process up to a life cycle that may be causing problems, or you stop and look at the files being generated, see what's going wrong. It's really nice to be able to stop the life cycle at a given point and see how far it actually got or what happened. And that's a very useful thing to do. Yes?
The modules you're talking about?
The plugins?
Yeah, well, you said there's a section with multi-modules. That means you have multiple POM files.
Multiple modules, yes, or multiple POM files, yes.
So you might be, would you be able then to build like a pipeline of, like if you had a project that's dependent on 3 other projects, and you want to make sure you had the most current, everything's current, so you would have modules to make sure 3 previous projects would be built first, and then build your final one.
Yeah, what happens is that we're talking about a multiple module project here in terms of what order things actually happen if you're doing a build with multiple modules. What's interesting is that when the Maven build first starts up, it's going to give you a list of the order that it's going to process the modules. And it does that by looking inside of the modules and the POMs and looking at all the different dependencies between them. And it might say, I'm going to process this one first and this one because there might be dependencies between them. They're going to be dependencies at the same level, in which case you have to make sure it processes one before the other. It'll figure that out for you. I have that situation right now where I have a parent POM, and I've got 2 children POMs, and one is dependent on the other, but they're both at the same level. Maven will compile one of them first, and then it compiles the other one afterwards. It's good at figuring out which one to do next, rather than trying to figure that out with an ant script or something like that. And somebody changes the name, and suddenly it doesn't work, and don't know what's going on. Okay, any other questions? Yes?
I have a question.
Yes.
Can you change the life cycle at all, either by creating your own life cycles or by adding new phases to an existing life cycle?
As best I know, the newer revisions of Maven added some additional life cycle phases. They added some additional phases. I showed 21. I think there's now 23, so I think they added a couple more. But the order stays the same. And if you don't use that particular life cycle, a step, it doesn't matter.
To a different set of phases, and
Your-
you can add different plugins to the different phases.
That's
I
correct.
can't go invent my own, sequence of phases.
As far as I know, you cannot create your own life cycle. I don't know. I don't think there is, but maybe they're giving the flexibility to do that. But in general, there really isn't too many reasons to do that, because if you've got 23 different types of phases you can attach things to, you probably figure out how to use that much more easily than trying to invent it yourself.
Most of people are adding plugins, they don't change
Yeah.
Okay, so let me give a quick presentation here in terms of what we can do. And this is going to be a little tricky because I have to work off. This screen is blank. Okay, so. Okay, so let me see if I can get this whole thing going. What I have here is a workspace which is currently empty. And I'm going to create a web application. And I can create it by using this particular command, which is now a little bit difficult to read on this screen. But basically, I'm going to use the Maven archetype generate. I give it a group ID, which we saw before. And we also have a particular artifact ID. I'm calling this web app 1. And the archetype that I want to use is a Maven archetype web app. So basically, this one command line is now going to generate a web application for me. All I do is just hit return, and it starts to run, assuming the network is alive in here. Let's see what happens. Okay, so it's asking me for additional information, which it didn't specify on the command line. We'll just pick stuff by default, and we're done. So let's take a look and see what happened. We see now we have a web application. That's as simple as it gets. So let's run that web application on STS here. What I want to do is import, and you'll notice that the import is a little bit different. Most of the time, you use the general existing projects, but this is a Maven project, and there's a special way to import this. You import using existing Maven projects. And we have the workspace here, CJUG1. We'll use that. And what's interesting is that rather than a project name or some kind of folder name, it considers the project to be the POM file. If it finds a POM file, it says, I know how to build that. I don't care what the rest of the files are. But that POM file tells me what to do. So when you're importing a Maven project, it's going to say, well, okay, we've got this POM file that we have to deal with. So let's go ahead and pull this in. And you see it's actually building the workspace, validating. It actually went through all those build cycles. So it basically gave us an application. And let's go ahead and put this on the server and run it. I don't think it's done yet. OK. OK, hello world. Now, this is the example that we got from the Maven archetype. But what I want to show you is something a little bit more interesting. And that is, what did the POM file tell us is going on? If we look at this, let's get rid of this junk over here. What's really important is, what's the POM file look like? If we look at this, there's not a lot of stuff in here. So basically, to create an entire web application, there's really not much stuff. We declare our name. We have the packaging type of war. Give it the artifact ID. The only dependency is JUnit. And what the build final name says, this says when we're done, just give it this name. So to build an entire application, all you have to do is have this very simple POM file. And all the rest of the stuff is handled by Maven defaults. What's interesting, though, is I want to show something called the effective POM. What this is basically assuming that everything had to be written in XML. What would you have to write? Well, there's a lot of stuff in here. What this is all the stuff that Maven gave us for free. And if you want, you can look through all of this stuff. It gives you a lot of folders, a lot of directory structures. It now is showing how it's going to bind all the different types of plugins to the different phases. Shows you how it's going to compile it. So all that stuff that we were talking about as far as default goals being attached to Lifecycles for us, very, very important that it does all this stuff for free. Very nice. What I'd like to do is show another more interesting example. Let's stop this so it doesn't mess us up. And this is how to use STS to generate a Maven project. So I want to do a new, I don't see it here. Let's go to other. A Spring template project. I want to generate a Spring MVC project. And the project name is, I'll give it something fancy like Web App 2. And my company name, what is that called? Vendeca Media, that's my company name. Anybody know what a Vendeca is? It's 1,000 to the power of 11. OK.
You're not quite a Googleplex. You're just a Vendeca.
You're just kind of really big. But you're not quite that big. Actually, it's the next proposed metric prefix for scaling large numbers. OK. So now we actually have a web application. And again, I'd like to take a look at what it generated in the POM file. And the POM file, we see, is a little bit more sophisticated. We have properties, but now we see Spring dependencies. So rather than downloading Spring, trying to unzip it, and trying to drag those jars around to the right places, well, we just say what we want is Spring context. What we want to have is Spring MVC. So again, this is the declarative nature of this. This is what we want. It goes and figures out how to get it. Effective POM is going to be a real mess, but let's take a look at some other interesting things, such as the dependencies. These are all the things that it went out there and it found and pulled in for us. And the dependency hierarchy. And this is where Maven is extremely valuable. For example, the Spring context is dependent on Spring AOP, which is dependent on AOP Alliance and Spring ASM. So we have actually a hierarchy of dependencies. How many times have you put a jar program in your application, you run it and it goes, jar not found, library not found? Well, that's happening because you're not putting all this other stuff in there. So Maven will take care of a lot of this stuff for you. Question or comment?
How does it know?
How does it know? I'll leave that for the experienced people to answer. Do you want to tell us how it knows?
All of these jars that are in the repository, when you showed us here in the local repository, it's got the jar, but it also has other metadata files. And for instance, each of the jars has its own POM XML companion file that in turn informs Maven about its dependencies. So Maven can chase down that tree.
Exactly. If you remember back the slide where I showed my local repository and I showed you my Postgres, I went all the way down, there was a POM file. It was actually the jar file, but it also had a POM file. That POM file says, well, if you want to use this jar, well, you got to go and get this other stuff too. But I only had to specify, I want to have the Postgres jar. And it pulled that in and goes, well, you got to go get this other stuff too. So again, all the stuff that's happening for you makes life a lot easier. So let's take a look at this particular web application. Let's actually go ahead and run it. And we'll start the server, and then I'll show you an interesting dependency. Okay, if we open the home page on this one, we see hello world. What's interesting about this particular one is it gave us a little piece of information through Spring MVC, which is what this particular project is all about. So what I'd like to do is look at the home page controller. Gee, I'm running out of space here. And this controller is very simple. It just creates the date. But what I want to do is I want to add something to it. I want to add to it some additional code, which I know will make it not work. And we'll see how easy Maven can solve the problem for us. So I had the formatted date, but now I'm going to do something such as this. And it goes, oh, I don't know what a JSON object is. Can you please tell me what a JSON object is? Well, I click on this. It's like, well, gee, I really don't know what that is. Maybe you should create the class JSON object for me. Well, I'm not going to create the class JSON object. I want you to go figure out how to get it. So we're going to tell this project through Maven how to understand what a JSON object is. Actually, let me stop this while I'm playing with the dependencies. OK. So what we can do is we have a shortcut in typing by copying this. And we pull up our browser. We go to the place where we find many of the jar files, which is our external Maven repository. And what do we see? We see, well, we have JSON here, and we have all these. Oh gosh, that's hard to read. What is this junk? Site development. I really don't care. Well, that's what I get for not having a full screen here. OK, so what's happening? The Maven repository, rather than Googling around and going to jars.com or some place that gives you plenty of advertisement like this, you can get all your jar files to this repository. And this is the JSON or dependency. And there are some dependencies here. There's different versions of it. There's the Maven, Ivy, Gradle, et cetera. So what I'm going to do is I'm going to copy this information. This tells us exactly how to get a hold of this jar. And we're going to take this and going to put it into that POM file. My arrow, there it is. OK. So my POM file was here. Let's go back to this. And what I'm going to do is go up to the dependencies section and just put that in. And now I'm telling this project that I now have a new dependency. Well, all I have to do is hit save, and it's rebuilding the project. So let's go back to our home controller and see what's going on here. So now it says, oh, by the way, now I do know about JSON. So let's go ahead and import that. So I didn't have to play around with jar files. And to clean up the code here, we have to throw this exception out. But you can see I did not have to go drag jar files or Google around for it. Went to one place, got the dependency. I didn't drag the jar, just drag the dependency over. Now we've got the dependency, we can go ahead and run this, and let's see what happens when we run this. Yeah, we come back here, and we're just going to do a screen refresh, and we see, voila, we're now formatted as a JSON object. So you see, it's just as simple as that. If you want to have additional packages, if you can locate it on Maven repository, just put the dependency in, and it basically takes care of everything itself. It's really easy to work with. So this basically concludes the presentation tonight. I wanted to bring everybody up to speed on what I think is a really cool build technology, having dealt with some really uncool build technologies back in those Linux days, or Unix days, I guess they were. But if you think about it, actually, Make itself did have dependencies, right? You have this file type. You want to go to this file type. And if this one is older, well, you apply some rule to do some kind of a building operation. So a rule-based build is really not that uncommon of a concept. Script-based building, like some other tools we don't like, kind of complicated that whole thing. But Maven actually made things a lot simpler for us. Again, by predefining a lot of stuff that normally you have to go figure out, by having a lot of defaults, by keeping track of this hierarchical repository, it makes your builds a lot easier to work with. And you can easily split these things into multiple modules, share your modules between other people. A very, very nice build system to work with. OK, any final questions or stuff maybe we can